Hi, everybody. Welcome to the self-check section 4.1 and 4.2 video. Let's go ahead and take a look at number one. So number one states, people visiting In-N-Out Burger often order more than one burger at a time. The probability distribution for burger orders per customer at In-N-Out is given in the following table, where we are only counting up to 5 burgers per person. So here we have a probability distribution table. We see we're missing 3, but we'll get there in a second. So part A says describe the random variable X in words. So what we want to do here is just describe what is going on in this example. So what we would say here is X equals the number of burgers a customer orders at one time. Okay. Second, for this exercise, what are the X values of X? And it's going to be the number of burgers they could possibly order up to 5. So it'll just be little x equals just 0, 1, 2, 3, 4, and 5. So they could also order 0 burgers. Okay, moving on to part C. Find the probability that a customer orders 3 burgers. So here's where we are missing that third probability for 3 burgers. So we know that all of the probabilities add up to 1. Okay, so what we can do is add up all these probabilities and subtract that from 1 to find that missing piece of probability. So let's go ahead and take care of that. So what we'll have here is, I'll say like step 1, we're going to add up all those probabilities. So 0.03 plus 0.50 plus 0.24 plus 0.07 plus 0.04. And so if we add all those up, what we should get is 0.88. Now, that's not what the probability is. It's just what all these are added up together. And what we can do is take the 0.88 and subtract it from 1 because we know all this adds up to 1 or 100%. So here we have, I'll do 0.00 for 1 minus 0.88, and that equals 0.12. So that's our missing probability for 3 burgers. So what we would say here for our final answer is probability of X equals 3 just equals 0.12. And that's our answer. Okay, moving on to part D, find the probability that a customer orders at least 4 burgers. So when it says at least 4 burgers, let me go ahead and add in our newfound probability, but at least 4 burgers, that means they're ordering 4 burgers or more. So this means ordering 4 burgers or more. And that translates to this notation, which means X is greater than or equal to 4. And so let's count that up. So probability of 4 or more, so that's 0.07 plus 0.04. Because that's 4 and 5, and that gives us 0.11. And that's our answer for 4 or more. Or, I'm sorry, at least 4, which is the same thing as 4 or more. Because the lowest they're ordering is 4. Okay. Sort of an opposite statement now. Find the probability that a customer orders at most two burgers. So if they're ordering at most two burgers, that means it is two or less burgers. Because the most it could go up to is two. They're still ordering zero, one, or two, but the most it can get is two, so it's two or less. And so the math notation would be probability of X less than or equal to 2. And what would that equal? Everything 2 or lower, so 0.24, 0.50, and 0.003. Let's add those up. 0.03 plus 0.50 plus 0.24, and that comes out to 0.77. So that's my answer for at most two burgers. Okay, moving on to the last couple questions. So on average, how many burgers would you expect a customer to buy? So here's where we need to find, let me go ahead and just move this down. Here's where I need to find the mean. That's what that average is telling us. So here's where we need to use our calculator. And when we use a probability distribution function, find mean, maybe I'll say use calculator. We need to put in our X values into list one and our X values into list two and do our one bar stats. So let's go ahead and jump to the calculator and figure that out. So on average, let me go to the calculator. So I need to put everything in our list one and list two. So list one is my X value. So here it's 0, 1, 2, 3, 4, and 5. And now I need to put in my probabilities for those respective burger orders. So it'll be 0.03, 0.50, 0.24, and then that one we found was 0.12. Oops, let me fix that. 0.12, 0.07, and 0.04. Okay, everything looks good. Now we got to go to stat, go to calc, and do our one bar stats. So we have list one. We need our frequency list. So we need to add in that list two. And let's go ahead and calculate. And here's what we get. So this X bar, that's our expected mean. So our expected mean is 1.82. Okay, let's go ahead and go back to the document and write that in. So here X bar, moving a little slow. There we go. So X bar equals 1.82. Okay, but since we are in a probability distribution, we are going to use mu. Sorry, my boom bar is in the way. There we go. Okay. Go mute. All right. So that's our expected value. So let's go ahead and write a statement. So I would expect a customer to order on average 1.82 burgers at a time. Okay, so now what is the standard deviation of burgers ordered? Let's go ahead and look at that. So notice here we don't have a sample standard deviation. That's because in a probability distribution, we don't have a sample, it's all population. That's why we use mu, because that means population. So here we have a population standard deviation, and that is 1.16. Let's go ahead and type that in. So back to the Greek letters. Remember, it's sigma. So here is sigma, and that equals 1.16 for our standard deviation. Okay. Okay, so that's it for number one. I'll cover the rest in the second video. Thank you for watching. I'll see you next time. Thank you. Bye.